All right, day 9 of Advent of Code. Day 8 was pretty hard, but we were able to solve it. So we're gonna get into day 9 right now. Yeah, like and subscribe. Let's get this work. Day 9, movie theater. You slide down the fire pole in the corner of the playground and land in the North Pole. Base movie theater. The movie theater has a big tile floor with an interesting pattern. Elves here are redecorating the theater by switching out some of the square tiles in the big grid they form. Some of the tiles are red. The elves would like to find the largest rectangle that uses red tiles for two of its opposite corners. They have a list of where the red tiles are located in the grid. Dude, largest rectangle, it's one of these ones. Showing the red tiles as the above will look like this. You can choose any two red tiles as the opposite corners of the rectangle. Your goal is to find the largest rectangle possible. Okay. That doesn't sound that hard. Showing 0 with area of 24. Or you can make a rectangle with area 35 between 7 and 1. Ultimately, the biggest rectangle is between those. Okay. What is the largest area of any rectangle you can make? Okay. Doesn't seem that hard. I think we kind of just need to loop through every single point and then just figure out the size of the rectangle that you can make between any of them. So pretty much the size of the rectangle is just the difference in x times the difference in x coordinates times the distance in y coordinates. Because the distance in y times the distance in x. So if the distance in, yeah, something like that. And then we just need to maintain a minimum. What is the largest area of any rectangle you can make? Okay, that doesn't sound too difficult. What do y'all think? We just do like a very basic double for loop and maintain the minimum value we find. Yeah, yeah. Toby, what's up? Have you already done these questions too? Yeah, focus on that. Hold up, need to sneeze. What's complaining? No such file directory as test.txt? Oh no, part one. For line 4 point in for point input string, we're gonna do x y equals point dot split. Then we're gonna do point dot append int x int of y. Now we have all the points. Now that we have all the points, what's the next thing to do? Now we just need to like compare the rectangle that we can make out of them. So I think we just need to do the change in x equals like import math dot absolute value between the point x minus the point y dy equals math. So we're just seeing the difference between the change in x over the change in y. Like the length of the sides, and then we return x. Max size equals float negative infinity. Start off with float negative infinity. We'll do max size equals max size. So rectangle size. Range. In range I plus 1 length the point. What we're going to do is for I in range length of points, what we're going to do is the max size equals rectangle size of points at I and points at J. And then we just put max size. Let me just look up absolute value in Python. You just say abs, you don't even have to use math. Just the answer. I'm probably just calculating. So let's just do 9 and 5, 2 and 5 and 9 and 7. Just my calculation is probably wrong here. How do you cancel this? Imagine I just vibe coded this whole thing. I should try after vibe coding advent of code. 24. Two and 9. One, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Let's add 1, I think. Yeah. Yeah. Just had to add 1. Get your puzzle input. This one's easy. Hopefully, let's see. Please, please. Let's go. Easy. Part 1 done. 12 minutes. That was the fastest I've ever got that one done. All right. Part 2. Someone came in the chat saying this was really hard. The elves just remember they can only switch out tiles that are red or green. So the rectangle can only include red or green tiles. In your list, every red tile is connected to the red tile before and after it by a straight line of green tiles. The list wraps, so the first red tile is also connected to the last red tile. Tiles that are adjacent in your list will always be on either of the same row. Wait. Every red tile is connected to the red tile before and after it by green tiles, okay? The list wraps, so the first red tile is also connected to the last red tile. Tiles that are adjacent in your list will always be on either the same row or the same column. Okay. In addition, all the tiles inside this loop of red and green tiles are also green. Holy, what? The rectangle you choose still must have red tiles in opposite corners, but any other tiles it includes must now be red or green. This significantly limits your options. For example, you can make a rectangle out of red and green tiles with an area of 15 between 7 and 3. Or you can make a rectangle with an area of 3 between 9 and 5. The largest rectangle you can make in this example using only red and green tiles, area 24. Why? Oh, because you have to use red tiles as opposite corners. What is the largest area of any rectangle you can make using only red and green tiles? Oh my god. Let me think about this. What is the largest area of any rectangle you can make? Like one thing I'm thinking if we just first switch out tiles that are red or green. So the rectangle can only include red or green tiles. In your list, every red tile is connected to the red tile before and after it by a straight line. So we could just fill this in. X. How do we fill in the middle here? This is interesting. Because what we can do is we can like just simulate all the X's or like figure out all the tile. We're already given the tiles that are red. We can figure out all the ones that are green. Okay, because this is our initial input right here. I have an idea for this. Yo, chat, who's still here? So what I can do is like connect, just start connecting them. Yo, cool, what's up? Do you get what's happening here? Just start connecting them like that. And then we just need to figure out how to fill this portion in. What if it's just like a big rectangle like this? Like, what if it's a... Yeah, we fill in the area. Then we just need to like start checking the 2 points between any 2 points, and then check if the we can easily find the corners, and then check it against the set. If both of the corners, if all four corners are colored, if all four corners are colored, then the whole area in the middle is gonna be colored. That's just like what's gonna happen for sure. That's just like the intuition there. So what if we just have like, but now we just need to figure out how to fill it in. What if we just have like a massive? How do we fill it in? Yeah, yeah. Well, okay, we don't really need to fill it in actually, because we just need to compare. It says Never red nor green. The rectangle you choose still have to be reds in opposite corners. So it still has to be reds in opposite corners. So we still need to choose. I think it doesn't even matter if we fill it in or not. That's like an extra thing. Because we just need to pick two, right? If we pick two, like what if this was just a dot, but then it was here instead? Yeah. Yeah, if this all we need to do is like check the 2 points, check the two hashtags, and then we need to calculate this point and then calculate this point and see if it's a green tile. If it's a green tile, if it's a green tile, then we probably know if it's a green tile, if both of these like new points, P1 and P2 are green tiles, we know that like the inner side is going to be a green tile because we know for sure this triangle is going to be green. We know this is green, but how do we confirm this is green? What if it's like crazy? I think we just had to take that shot. Yeah, if we look at any 2 points after we colored any 2 points, like after we colored any 2 points, like all four corners are like if we compare any 2 points, all four corners are gonna be like one of the things. Right? Because we're gonna be comparing hashtags. So if we compare this hashtag and this hashtag, yeah. If we compare this hashtag and this hashtag, yeah, all of them are gonna be either green. If we color the outlines, we're good. What if these two? Oh no, but we need to catch the middle here. Oh yeah, we need. Yeah, we need to check. No, we need to fill it in though, because look, if we're looking at square and square here, it's comparing x's that are like not in the. But how do we know how to fill it in? Because look, this square and square, it can form an area, and who knows if like one of the interior ones is actually the largest, like or like this one and this one. Yeah, yeah. The result includes okay. The result already includes like one of the middle, so we need to know. We need to kind of fill in the middle. The we kind of need to fill in the middle because the result contains the middle. How are we gonna fill in the middle? Okay, we can like flood fill from the outside. We can like put these ones and then just fill in from the outside until we hit the barriers. Yeah, we can fill we it's like Pacific water like you kind of fill you can fill it from the outside, and then now we know the interior, and then from there we could just we can just like add that to a set. Okay, let's implement that. I think that would actually work. And then that's not going to be that slow of an operation. I don't think. Wait. Yeah. But the input, what is the grid? Oh, we kind of just need to fill it from the inside. Let me think. How do we fill it in? Okay, we might get ideas from like looking at the like what I'm thinking is like if it was a small grid we can fill it in, but like otherwise but like these are like large numbers. So what we need to do is just like figure out how to fill all these elements in. Bro. This is a good one. Yo, do you know how to fill this in? Paul, what are you thinking? Yeah, these numbers are too large. Okay, how do we check if a point is like how do we know that this point is gonna actually be green without like pre-computing it? Okay, we need to look at it like that. Yeah, drop my I don't think I solved the problem like this before, to be honest. Drop my water. Need to think about this a bit. Oh, oh no. Cause it's easy to fill by a straight line of green tiles. The list wraps of the first red tiles also. Okay, we connect this. Let's look at the input. I think we just need to simulate the input, then it might jog our memory. 7-1. Two, three, 4, 5, 6, 7, 8, 0, 1, 2, 3. Okay, 7-1 and 11. 11-1. 11-1 and 11-7. 11-1. Okay. What do I know here? What do I know here? Like, how do I fill in the middle? Okay, 11-1 connects to 9-7. 9-7 connects to 9-5. 9-5 connects to 2-5. 2-5 connects to 2-5. Yeah, connects to 2-3. 2-3 connects to 7-3. 7-3 connects back to 7-1. Yeah, this is so funny. In every red house. So I wonder if we could just like push this. Push the neighbors. Like when we're connecting. Oh, we could start filling in from the corners. Because we know these two. Right. Yeah. It's gonna if it's like has a lease. Oh no. How do we know it's gonna be in the corner though? Like how big is this Euclidean plane? Let's just calculate it. We'll see the minimum x and the minimum y. min y, max y. Then we'll do min x equals min of min x and min y, max, 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 y. So we're gonna always look for the min. X. I'm just trying to see like the coordinates, like the size of the grid. How do you fill this thing in? Because now it's enclosed. You know we're gonna go in this direction. It's not crazy. It's like just 10,000. Yeah, we can just flood fill from the outside. I don't think like we can just like go from like literally just flood fill starting 0, 0. And then just like go to 100,000 max. For point and input string split. So minimum of x, we're always just keeping the minimum of x. We're always keeping the minimum of y. Then we figure out the maximum of x. So now we know that the grid is like 0 to 0 and like 10. We can just go like 10k. Oh, wait. Okay, the minimum x and the maximum x. Yeah, it goes to like 100k here. and like 100K here. How many cells is that? That's a lot of cells. To run. I wonder how long that, like, how. Woo! Could take 3 minutes. Yeah, it's not possible. We have to kind of fill it in from the inside. Yo, I don't know how to do that. Chat. How would we fill it in from the inside? Or how do we even fill it in at all? Yeah, I agree, man. Did you finish this question? Bro, who said he did it? Where's this guy at? Dude, I don't know how to fill it in. Bro, Paul, how do we fill in this? How do we fill in like we're basically I'm able to figure out that like we need to fill in like a shape like this in green. But we can't go from the outside. So I was thinking, yeah, maybe we can go from the outside and just do like a and just do like we can go from the outside and just do like a flood fill. But it's 100,000 by 100,000 the grid. Cause we can like fill it until we hit any of the corners and then we're done. But we can't do that. So we need to fill it in from the inside. So now we just need to figure that out. Like just fill in. Like there's a question called like flood fill. How do we fill any rectangle? Oh, really? How do we fill any like it doesn't need to be any if it's a rectangle it's easy. You just click that. You pick the two, you fill it. Or is that similar to all we have to do? We just pick any two. Nah, because if we pick these two rectangles, we can't fill it. Yeah, the shape is only made of rectangles. Dude, like I want to do a BFS. I want to do a BFS, but the thing is, like, how do I know which directions to push in? Do I just push in? What if because suppose like I do a BFS and I push in these neighbors. How do I know I'm in bounds? What if this one connects here? Connects here. Wait. Like that. Yes, just straight lines. So we just do straight lines. Yeah, we're gonna get the straight lines, but I just need to figure out since it's a convex shape, you can check the bounds. Paul, essentially, this is what it does. First off, all it does is gives you the different points, right? Let's see. Like 7-1, right? Yeah, so it gives you all these points, but it gives you it in order. So it basically says 7-1 connects to 11-1. 7-1 connects to 11-1. 11-1 connects to 11-7. And then 9-7, 11-7 connects to 9-7. 9-5. So definitely I'll be able to like connect these. And they're like these are all adjacent to each other. Compress the grid. Oh, you're right. Maybe if it sees it twice. So this is what we're gonna do. We're gonna connect here and we're gonna put like we're gonna mark all the neighbors with red while we're connecting. Oh shoot. This is what we're gonna do. Maybe like yeah, like as we're connecting the line, we're gonna draw the neighbors with red. Right. Then when we go here. If it we'll do red, 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 red. If we see a orange, that means it's gonna be red, red, red. Like if we see it twice, then we know it's gonna be a point. Go blue. Red. And then this becomes a point. Go blue. Like that already became a point, but we go red. Okay, so we need to count these points too. We need to push all these neighbors. Just adjacent like that. And we see this. Does that work? Go here. Oh no, because like yeah, these are gonna overlap. Wait, so how do we compress it? Maybe we can think of it like layer by layer. We know that when we connect here, it's gonna be a layer. How do we know to like do this next what like would we know to do like this next layer? Yo, if we did BFS from the outside, if we did BFS from the outside and we use multiple threads, I feel like it could fill it up way faster. Like one just filling here. It's not IO bound, is it? This one was filling it. Then it just uses the shared thing. Like if we're using some other programming language, it would just if we can just fill out from the outside, from the four corners, and they will just fill theirs out independently. And then they'll all like converge. If we had multiple threads, it would finish faster. Maybe we could just like fill from the outside. I think yeah, we can just fill from the outside because we won't actually hit all 10 billion rows. Let's just fill from the outside. So we could just like perform like a BFS. It won't actually hit 10 billion rows probably. And it says it's only going to take like a 3 minutes to run. Then we'll just save that for like, we'll save that set somewhere. As long as, like, I don't care how long it's going to take to run as long as it finishes running, you know what I mean? So we could start at 0, 0 and just do a BFS, flood it, like flooding everything in. And if it hits a corner, we're good. And like the out of bounds is like 10K or 100K. So like, and then we know like who's a tile or not. Does that make sense? So let's just implement this real quick. Otherwise, we'll come back to it tomorrow. Or what we're gonna do is we're given the point. So we have our input string. I'm gonna like just modify the grid so I'm gonna create a grid. Grid equals one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9. 14 by 9. So 9 rows. Sure. So the grid, there's actually y. X. Kind of reverses it. Okay. Now we just need to fill it in. Fill in the borders for range length points. One equals points at I minus 1 point. Now we just need to fill in the border. Same x equals point A 0 equals point B. So they're gonna be at the same x or same y. Then we just need to look at the direction. Point x. Yo, Paul, it turned up on us quick, huh? Same y. Oh no, it's reversed, yeah. Same X, same Y. Same X, same Y. Okay. Now what we're going to do is if same X, then we're going to do one thing. Direction equals if it's the same X, then we're going to do point. You think we can just brute force it like this though? -1 if what if but increase the columns. Is this a LeetCode hard question? Maybe, probably. Point A. Why is that 0? Oh, okay, because we have to. Okay, they're on the same Y. Wait. I'm flipping these around. Let's just make sure. It gets trippy when you're using rows and columns and then you switch. Okay, these are in the same. These aren't on the same X or in the same Y. Same Y, same X, same Y. Okay, okay, okay. Point A. Okay, these are same y, so we have to look at the x coordinates. Oh, we just have to flip these. This one's cooked. So they're the same y. Okay, the direction there. Same x. Then we just increase. Same y. Negative. Same x. It's the same x. So we have to. Okay. Now we just need to fill it in. Wow. How do you do fast in DFS? So now we connect these. We go iron range. How do you figure out fast in DFS? What? I just checked pairs of points, and if none of the other points were inside the rectangular generated by the 2 points. How would you know none of the other points were inside the rectangle generated by? How do you know if the other points were inside the rectangle generated by the 2 points? Without filling it in. If it's on the same X, then we need to go. How do we connect them? This one's gonna be on the same Y. If they're on the same X, or I don't even. This question is cooked. Okay, we don't need to check the direction. We just need to check if they're the same X and same Y. Then we need to check the distance. Then we need to figure out the one that's on the if it's on the same Y, we just need to check the distance. Then we need to find the leftmost. Midpoint line generating. What do you okay, wait, let's think about that. What Bro, that's crazy. I've never took a class like this. Yo, M, is that how you solved it? Holy crap, raycasting is tweak. I'm gonna just fill it out brute force right here. I'll look that up in a sec if I can't fill this in. For I and the range distance, You just took every possible pair of red tiles as opposite corners? And then what though? How do you check that the how do you check that the other four corners are in are like in the thing? I see. Oh, okay. I see. I see. That's interesting. So we just take any we can kind of just take any 2 points, right? And then like scan until we go like this. We could just scan. Like we can take any of these 2 points. Like these corners. Then we could just like try and then we can calculate these corners and then we could just see if there's any edge when we go here. See if there's any edge here. See if there's any edge going here. If there's an edge, if there's an edge, then it doesn't count. Okay, I think that makes sense. Cause like, what if we do pick these 2 corners? When I'm like, I'm trying to look for this one, I see an edge, so I know that like, so I know it won't work. If I go here, I don't see any edges. If I go What about here? Here. But I see an edge here. Not really though. Wait, what? How do we capture this though? Okay, we. Oh man, this is crazy. How do we do this? Dude, this is a good algo. This is just 2D though. What the? No way. That's the code. No way. That's the code. I don't know if I'll be able to get this today. All right, chat. We're gonna get back to it. We're gonna think long and hard about this one. We got the first part, but we're still gonna get that for sure. We're eventually gonna get that. I can't figure it out today, and I gotta sleep for work. I gotta commute early in the morning. That's a hard question. Like trying to fill these in. What I was gonna try to do is just fill in these edges and then like BFS from the outside. And then like try to fill it in, but we kind of need to like fill it in. Yeah, dude, this like ray tracing. I need to figure that out. Yo, Paul, send me some stuff related to that. I'll read up on it and then hopefully we can implement it tomorrow. But man, we got folded. We got folded. At least I know my limit now. But tomorrow we're gonna keep going until we got this. All right. Catch you on the next stream. Thanks for helping out. We spent about an hour and a half in that, but made some progress, but couldn't get it. But yo, Paul, send me some notes on that. I'll see y'all in. I might see you in the office on Wednesday. But peace. Thanks for tuning in.